This is the first OSPF lab. This OSPF domain has several areas. OSPF version 2 is being used, so only IPv4 is supported. So let's go to action item number 1. Why routers 1, 2, 3, and 8 are not sharing any routes with one another. So let's go and see what's going on. If I go to router 1 and I issue show IP OSPF neighbor, I can see that it is in loading state. Show IP OSPF neighbor. This one is showing the DR and the BDR as down. Show IP OSPF neighbor. Down. Show IP OSPF neighbor. Init. So they are surely reaching the loading state, and then they cannot go any further. When this happens, when the loading state is stuck, what happens is that you have an MTU issue. So let's see if all the routers have the same MTU in order to check if there is an MTU mismatch. So we have jumbo frame in router 1, so interface gigabit 00. Jumbo frame in router 2, interface gigabit 00. Jumbo frame in router 3, and jumbo frame in router 8. So the MTU is correct in all the routers, but let's see the switch that is connecting them. Show interface gigabit 00. It does not have MTU. So here is where the problem lies, in the switch. So let's also see how is the VLAN being configured. It has an MTU of 1500. So notice that you cannot change the VLAN 1 MTU. If you want to, it will give you this error. So what we're going to do to fix this problem is creating a new VLAN, setting this VLAN, the new VLAN, to jumbo frame, and configuring all the interfaces in the switch with jumbo frame. So let's create VLAN number 2, MTU 4000. Let's go up now to the interface range, gigabit 0, 0 to 3, and then change the VLAN, switchport access VLAN 2, and set the MTU to 4000. So now the switch is configured to use jumbo frames at the port level and at the VLAN level. So let's check. Show VLAN ID2. This VLAN supports jumbo frames, and we check the interfaces. Now they have jumbo frame enabled. So now we should see that these neighbors should start to go into full state. That will happen slowly. So we'll have to wait a bit until this starts working. Meanwhile, let's go to action item number 1.2. Who is currently the DR and who is currently the VDR? Router 1 should be the DR and router 2 should be the VDR. So let's go to the routers and see who is the DR and who is the VDR. Show IP OSPF interface gigabit 00, and it tells me that the DR or designated router is the router 8, and the backup designated router is router 1. So let's go to the interface gigabit 00 and set the IP OSPF priority 200, and let's go to router 2 and do the same. intermediate 00, IPSPF, priority 100. Now we have to make router A to give up its role because we have no preemption, so we have to clear the process. Yes. So now router 1 should be designated router, and router 2 is the backup designated router. Let's see how the neighbors are going. Let's remember that router 8 just got restarted the process at least. Now we have full, they are at full adjacencies. Show IPSPF neighbors, full. There is a, okay, show IPSPF neighbor. So notice that between there others, they will never reach the full status because in broadcast networks, the state of full is only achieved with the DR and the VDR. So this area is fixed now. Let's go to action item number 2. Figure out why router 1 is not becoming a neighbor of router 4. So let's go to router 1. And let's issue the command show IPSP neighbors. I don't see router 4 here. Let's go to router 4. Show IPSPF neighbors. I don't see router 1 here. So there's something going on. For some reason, they are not becoming neighbors. Let's see if the connectivity is correct. They are connected to this interface. I'm going to pin router 1 from this end. It's reachable. I'm going to pin router 4 from this end. No, sorry, that's not the IP address. It must be 14. So it's reachable from both ends, so there is connectivity, yet they are not becoming neighbors. Remember that in order to become neighbors, two devices must abide by certain rules. So let's issue show IP OSPF interface packet over sonnet 5/0, and we can see here more details. And remember that in order to become neighbors, they must have unique router IDs. They have it. Okay, the router IDs are different. They must belong to the same subnet, which is this /24, which is this /24, and they must belong to the same area. This is area 1, and this is area 11. So here is the mismatch, the area number. So we can go to router 4 and see what's going on with the area. See, let's see how it is configured. So it is configured correctly in the router OSPF process. This is the IP, this is the network command, and it is saying that the area should be number 1, but nevertheless, we are seeing area 11. So let's see what's going on with the configuration of the interface. See if there's some problem here, and here is the problem. There is an OSPF level, interface level command that overrides it. This command is overriding this command. So remember that OSPF interface level commands always override network commands. So let's fix that. So now it belongs to area 1, and the neighboring should come up. Show IPSPF neighbors. Now we are neighboring with router 1. Okay. So let's go to action item number 3. Validated area 2 has no connectivity to area 1 or to area 0. So this is a thing that is seen in many labs. As you know, there is a failure of design here. Area 2 must be connected to area 0, otherwise it will not receive any route. So this is a bad design, and what we have to do is, well, let's check that we don't have any route here. No OSPF routes. The database is almost empty. Only LSA 1 and 2 coming from the same area. So we need to establish a virtual link. Let's configure this virtual link. Router OSPF1. So what we're going to do is to create a virtual link between this router and this router. So router 4 will have a virtual link that is connected to area 0. So router 4 can then connect area 2 to area 0 through that interface, that virtual interface. So let's create that virtual interface that is known as a virtual link. The transit area is area 1, virtual link, and you must be careful here. The IP address that you enter here is the router ID IP. It is the router ID, I'm sorry, that belongs to the other router on the other side of the virtual link. It usually happens that you will enter here and the physical IP address of the other router, but that will be incorrect. So remember to use the router ID always. So let's do that here. Router OSPF1, area 1, virtual link, and the router ID of the other end. So we can show OSPF interfaces and see that the virtual link just came up and it is up. So now router 5 should be seeing all the LSA 3s that are coming from the ABR. Now the ABR is this router for area 2. The ABR is router 4. The router that lets area 2 connect to area 0 will be router 4. Okay, so let's see the routes at router 5. Show IP route OSPF. Okay, we're seeing all the routes coming from area 0, and they are inter area routes. So and notice that router 4, given it has a virtual interface landing on area 0, behaves as if it was a router that belongs to area 0. So all the routes are considered to be inter area. So let's go to the next action item. Action item number 4. Area 2 is not very secure. It has many external users, guest providers. So we want to have neighbors at switch 1. So we want to become this neighbor between router 5 and 4 is legal, but we must use authentication. So let's go and configure authentication at router 5 and 4. So let's go here and let's configure gigabit 00 IP OSPF authentication message digest IP OSPF message digest 1 MD5 and cool lab will be the key. So I'm going to configure MD5 on this side. How I can validate it with show IP OSPF interface. I can see that I have message digest. The neighboring should have come down. Didn't come down. Where did I configure the gigabit 00? Okay, I have configured authentic. Okay, now the neighboring came down after the timer elapsed. So let's configure authentication on this side so that neighbor can come up again. So IP OSPF authentication message digest, IP OSPF message digest key number 1 MD5 to LAB. So this key must match in order for this to work. So IP OSPF interface, and I can see that I have message digest on this side. And let's see if the neighbor came up again. Okay, it's working now. Okay, action item number 4.2. You don't want to have neighbors on switch 2. So make sure that router 6, which is a rogue router, does not become a neighbor of routers 5. So router 5 is the edge of our domain, and we don't want routers, foreign routers, to become neighbors of our routers at our domain. So make sure router 6 does not become a neighbor, but you want that users that are connected to this network still must be able to see our access our OSPF domain. So we don't want to affect the users, but we don't have to have neighbors. So in order to do that, we will have to go to router 5 and go into OSPF mode and use the passive interface for gigabit 10 for gigabit 10. So we don't want neighbors there. So if we issue that again, we got rid of that rogue router that was becoming a neighbor. But however, we still want this network to be available in my domain. So let's go here and see if I have that network. So IP route 10.1.3.0. I still have that network. I can ping it. So the users of that network are not affected. The only thing I did was avoiding to have routers, foreign routers, or rogue routers creating a neighbor relationship with our border routers. So let's go to action item number 5. Reduce the amount of networks coming from area 0 to other areas, particularly these two. So let's go into create a summarization for area 2, so it does not receive so many routes. That summarization will have to be done at router 4 because as far as area 2 is concerned, router 4 is the router that connects it to area 0 because we have a virtual link here. So let's create that in router 4. Let's see the amount of routes we have at router 5. Let's see, we want to summarize all of these routes. There are so many, 16 and 17 routes. So let's go here, router OSPF 1, area 0 range, everything that comes here, advertise, and 17. So let's see if that worked. So that worked like a charm. We reduced all those routes for those two Class B networks. So now from router 5, I am only seeing these two summarized prefixes. Okay, let's go to action item number 6. Area 2 must not have access to these networks. So when we just filter them, but the lab said to remove them from area 2, use summarization to filter the 16 network, and use a prefix list to filter the 17 network. So let's, the first one is easy because you only have to go here and the 16 route. We're going to enter this command again, but we will use the no advertise. No advertise, so I will be not advertise. So I just filtered out this from area 2. So now I am not seeing anything related to the 172.16. So the 172.17, I'm going to filter using another method. Let's see here. Let's go to router 4. And let's configure first prefix list, like IP prefix list, now 17 network, maybe sequence 5, deny, everything that starts with 172.17.0.0/16, maybe in greater equal 16. So greater equal, let's do this, then IP prefix list, now 17, sequence 10, and permit everything else. 0.0.0.0, lower equal 32. So I'm going to change this. I'm going to use this. Okay, so now let's go to router OSPF 1 and do area 0 distribute list. I'm sorry, filter list. Prefix now 17 out. So let's see if that worked. Let me erase the. I'm going to erase the OSPF. I'm going to erase the summary for 17 network. Okay, now I used a filter in order to remove all the 17 networks from being advertised with this configuration. So let's see. So IP prefix, now 17. This is the prefix list, and the configuration was show run begin router OSPF. So I am filtering the 17 networks with this command. I'm filtering the 16 networks with this command. So great, let's go to next. Router 5 needs only to know about this particular 18 network, 172.18.1.0/24. So let's do a distribute list there, because router 5 has still lots of routes. So maybe I just want this router to know this route. This is the only route that it needs. I want to filter out these routes from landing into the database. So let's do that. So let's create prefix list here. IP prefix list, permit, I'm sorry, 5, permit. I'm going to permit only this network /24, and I'm going to deny everything else, or maybe I will let it that way, and do router OSPF 1 distribute list prefix. Oh, sorry, I didn't name it. IP prefix list. only one, sorry, permit. Yes, I forgot my prefix lists already. And that's it. So router, OSPF, distribute list, prefix, only one, and so let's see, that's only gave me this this prefix, but if we examine the database, I will still see all the 18 LSAs. So remember that local filtering will not stop LSAs from landing into your database. They will still be received in the database, but the resulting of this calculation will not land into the route table. So you will still be using space, memory space for your LSAs, but you're not seeing that in the routing table. So let's go to action item number 8. The link between routers 3 and 7 has been down for more than 30 minutes. Hence, the area 0 is not contiguous anymore. So this link has been down for a while. Let's go to router 3 and see how is the database looking. So show IP OSPF database, and we can see that this LSA that was created by router 7 is already over the 1800 threshold. All LSAs are supposed to get renewed after 1800 seconds. So you can tell that something is going wrong with a router if that router has not renewed its LSA. So once this LSA reaches 3600 seconds or 1 hour, this entry will get erased from the database. So, but in the meantime, you can tell that something is going on with this router if this value goes beyond 1800. So that's it.